In this activity, we're trying to understand the meaning of square roots. So, finding the square root of some number. And we're going to be looking at some squares, which is part of why this is called a square root. First, we're going to look at the areas of these shapes right here, these squares. The area of this square right here, we can see that it is 1. The area of this square is 4. 1, 2, 3, 4 square units. The area of this square is 9. The area of this square is 16. And the area of this square is 25. If we look at the sides of each one of these squares, we notice that the sides of the square are 1 unit in length. The ones in this one are 2 units in length. And the ones in this are 3 units, 4 units, and 5 units. And it doesn't take much thinking to see that if we multiply 5 times 5, we get 25. 4 times 4, we get 16. 3 times 3, we get 9, and so on. So, because of this characteristic of the areas and the size of squares, the 5 is called the square root of 25. Meaning that if you multiply 5 by itself, you get 25. And the reason is because 5 times 5 gives me 25. The square root of 16 is 4. The square root of 9 is 3. The original meaning of square root was the number that when you multiply it by itself, the answer is 16. The number that when you multiply it by itself, the answer is 9. The number that when you multiply it by itself, the answer is 4. So we're looking for numbers that when raised to the second power, you get the other number. Now, the area of this square is 2. The area of this square is 1 plus 1 plus 1 plus 1 plus 1. 1, 2, 3, 4, 5. The area of this square is 5. The area of this square is, we have half of 3, another half of 3, half of 3, and half of 3. So 2 halves of 3 give me 3. So 3 plus 3 is 6, plus 4 is 10. The area of this square is 2, 4, 6, 8, plus 9. It's 17. So, in the same way that we were looking over here, there should be a number that's this length right here, that when you multiply it by itself, the answer is 2. There is a number, in this case this length, that when you multiply it by itself, the answer is 5, and so on. So we're going to try to find these numbers. Now we're going to use this program to find the distance between the length of the sides of these squares that we found the areas before. 2, 5, 10, 17. The distance between W and X is 1.4. The distance between these 2 points, 2.25. The distance between those 2 points, 3.15. The distance between those points, 4.12. These measurements that we find here, 1.4, 2.25, 3.15, and 4.12, are approximations of the real distances because the square roots are non-repeating, non-terminating decimals. We can check that by finding 1.4 times 1.4. 1.4 to the second power is 1.96. We had found that the area of this is 2. So 1.96 is approximately 2. We can check this one and see what happens. 2.25 to the second power is 5.06. The area that we have calculated by looking at it is 5. So it's very close to the real area. And the same thing would happen with these other measurements, because these distances that we find are approximations due to the fact that square roots are very complicated numbers. They are non-repeating, non-terminating decimals, except for the ones that are the square roots of perfect squares. If you have a perfect square, the square root is going to be a whole number.